Heya. I have recently encountered a new to me way to factor, and I want to share it in case it's new to you too. Okay, let's go. Okay, so let's start with this quadratic. In doing this method, our first step is to multiply the coefficient of our x squared term, the a, times the constant term, the c. 2 times negative 12, that gets us negative 24. Okay, now we're going to rewrite this term minus our a, and we're going to bring our b straight down. And now we're going to go ahead and factor this new equation. All right, so what multiplies to negative 24 but adds to 5? Well, I see our factors 8 and 3 as looking pretty good. And to end up with a positive 5, I need that to be a positive 8 and a negative 3. And then because this is just x squared, that's x and x. All right, our next step is to go ahead and take this coefficient that we dropped and divide each of our constants by it. All right, if either of these two further reduce, we do that. And so 8 over 2 reduces to, and that term is now done. That is one of our factors. This next term, because this doesn't reduce to an integer, what we do instead is we take this denominator and we swing it around to make it a coefficient here. And that is our second factor. And if we FOIL these out, x times 2x gets us 2x squared. X times negative 3 gets us negative 3x. 4 times 2x gets us, and 4 times negative 3 gets us negative 12. And when we simplify our middle term, negative 3x plus 8x plus 5x, and there we are, same as where we started. So I'd never done it that way before, but it's pretty efficient. Let's try it again with one where the coefficient of our x term isn't a prime number, where there are multiple factors it could be. So let's take a look at that one. 6x squared minus 7x minus 5. Okay, first step, a times c. That gives us a new constant of negative 30. Our new leading term is just plain old x squared, and our b remains the same. Okay, now we're going to factor that one. I know x and x are my first term. I look at what multiplies to negative 30 but adds to negative 7. I'm looking and seeing a 10 times a 3 is going to work. And I see that to make a negative 7, my 10 wants to be the negative number. Now I take the coefficient I dropped and I divide each of my constants by it. And I further simplify. And I see that neither of these are integers. So I take each of these denominators and swing it around to become the coefficient instead. And that is my factorization, and I can do a quick FOIL to make sure I'm right. 3x times 2x gets me my 6x squared. 3x times 1, that's plus 3x. Minus 5 times 2x, that's minus 10x. Minus 10x plus 3x gets me my minus 7x. And minus 5 times 1 gets me my negative 5. All right, stay tuned. It's driving me crazy why this works, so I'm going to try and do a derivation with like ax squared plus bx plus c and see if I can work out why this method works out. But meanwhile, it does work, so there's another way to get your quadratics factored. All right, leave any comments or questions you've got that you'd like me to take a look at. Take a look at my playlist on factoring for more factoring practice. Consider subscribing to my channel so you know when I drop a new video. And as always, keep on mathing.